A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. I have to tell you, Herman, watching Hilbert Flumingdop try to explain the new Algolia integration on the website yesterday, it was a spiritual experience. I haven't felt that out of my depths since I tried to assemble that Swedish bookshelf with a single hex key and a dream.
Poor Hilbert. He was so excited to show us the ranking nested attributes, and I think we both just stared at him like he was reciting ancient Sumerian poetry. But honestly, it's a perfect experience of how the search bar has gone from a simple text box to a full-blown AI decision engine. It's no longer just a matching tool, it's a prediction tool.
It's deceptive, right? You type a word, you get a list. How hard can it be? But today's prompt from Daniel is asking us to pull back the curtain for the mere mortals. He wants us to break down the complex world of modern search systems, fuzzy matching, semantic search, re-ranking, and actually give small teams a guide on how to tune this stuff without losing their minds.
It's a great prompt because the landscape has shifted so fast. By the way, fun fact for the listeners, Google Gemini 1.5 Flash is actually writing our script today, which is fitting since we're talking about the models that power the very things we're discussing. Herman Poppleberry here, ready to dive into the weeds.
And I'm Corn, ready to make sure we don't get stuck in those weeds for 30 minutes without a map. So, Herman, let's start with the why. Why is this so much harder than it was in, say, 2010? Back then, you just indexed some keywords, hoped the user spelled them right, and called it a day.
The bar for useful has moved. In 2010, if you searched for red running shoes and the site gave you a list of shoes that had the words red, running, and shoes in the description, you were happy. Today, users expect the search to understand intent. They expect it to know that if they type crimson joggers, they probably want those same red running shoes. They expect it to handle typos perfectly. They expect it to know what's popular.
Right. We've been spoiled by Google. We treat every search bar like a sentient assistant. But for a small team like Hilbert working on our site, you're suddenly faced with a dashboard full of sliders for typo tolerance, vector density, and attribute weighting. Where do you even begin? Is there a correct first step, or do you just start sliding things around until it looks right?
You start with the most basic layer, which is still the workhorse of search, fuzzy matching. This is essentially your typo tolerance. If I type iPhone instead of iPhone, fuzzy matching is what saves me from a zero results found page. Technically, it's usually built on something called Levenshtein distance, or edit distance.
I remember Hilbert mentioning that. It's basically counting how many moves it takes to turn the typo into the real word, right?
Swapping a letter is one move, deleting one is another, and adding an extra one is a third. Think of it like a game of Scrabble where you're trying to fix a mistake with the fewest possible changes. Most modern systems, like Algolia or Elasticsearch, default to a distance of 2 for longer words. But here's the trap for small teams, they think. Well, if some typo tolerance is good, more must be better. So they crank it up to 3 or 4.
And suddenly a search for cat returns results for car, cab, cap, cap, and maybe bat if the system is feeling generous. I can see how that would get messy fast. If I'm looking for a pet, I don't want a baseball accessory.
That's the noise problem. If you're too aggressive with fuzzy matching, your precision plummets. You're getting high recall, meaning you're finding lots of stuff, but the precision is terrible because half the stuff isn't what the user wanted. The rule of thumb I always tell people is to keep it tight. You generally don't want a typo distance of more than 1 for short words like 3 to 4 letters and maybe 2 for longer ones. If the user is 3 or 4 letters off, they're probably not just making a typo. They might be searching for something else entirely, or they're just smashing their keyboard in frustration.
But how does the system know which word is the right? One if two words are the same distance away. If I type NA, and it could be pen or pin, how does it choose?
That's where popularity or global rank comes in. The system looks at which of those two words is more common in your index or which one gets clicked more often. It's a tiebreaker. But okay, fuzzy matching handles the fat fingers problem. But what about the I don't know the exact word problem? That's where we get into the buzzword of the decade, semantic search.
This is the one that sounds the most like science fiction. I hear people talking about it like it's a mind-reading device.
This is where it gets really cool. Semantic search moves away from matching characters and moves toward matching meanings. It uses vector embeddings. Essentially, you take every product or article in your database and run it through a model that turns the text into a long string of numbers, a vector. These numbers represent the coordinates of that concept in a multidimensional space. We're talking hundreds or even thousands of dimensions.
I love the mental image of a giant 3D cloud where Apple, the fruit, is floating near pear, but Apple, the tech company, is floating way over by Microsoft and Silicon. It's like a map of human thought, but for machines.
That's exactly how it works. When a user types a query, the search engine turns that query into a vector too. Then it just looks for the items that are mathematically closest to that query vector using something called cosine similarity. This is why semantic search can return boots when you search for warm footwear, even if the word warm never appears in the product description. The model knows that boots and worn footwear occupy similar conceptual space.
It sounds like magic, but I know there's a catch. Hilbert was complaining about the latency and the compute cost of this stuff. Is it actually practical for a small site?
It's heavy. Comparing vectors is much more computationally expensive than checking if the letter A exists in a string. If you have 1 million documents, doing a full vector comparison for every search query would be incredibly slow. That's why companies like Algolia or Pinecone use neural hashing, or approximate nearest neighbor algorithms. They compress those complex vectors into a format that's much faster to search. But even then, for a small team, you have to decide, do I really need a full semantic model for a simple inventory of 50 items? Probably not. If you're selling 50 types of screws, a keyword search is going to be faster and more accurate.
So if I'm a small team, how do I decide between the old school keyword matching and this new school, semantic search? Do I have to pick one side and stick to it?
No, and you shouldn't. This brings us to the hybrid retrieval pipeline, which is really the gold standard right now. You combine the two. You use keyword matching, often called BM25 in the industry, for the exact hits. If I search for iPhone 15 Pro, I want the exact product page, not a conceptually similar Android phone that the AI thinks I might like. Keyword search is keen for specific names, part numbers, and technical terms.
But you use the semantic layer as a safety net? Like a backup dancer for the lead singer.
Right, you run both simultaneously. The keyword search finds the exact matches, and the semantic search finds the intent matches. Then you merge the results. It improves relevance by 15 to 30% over using just one method. But then you hit the next big headache. How do you decide which result goes at the top? If the keyword search says result A and the semantic search says result B, who wins the prime real estate at the top of the page?
That's where the re-ranking comes in, right? The final boss of search complexity.
It really is. Re-ranking is an additional AI layer that sits on top of the initial results. Think of it like a second pass, the first pass. The hybrid search grabs the top 50 or 100 possible matches very quickly. Then, a much more powerful, slower model, often a cross-encoder, looks at those 100 results and the user's query and says, okay, let's really think about this. Which of these is actually the best?
It's like a bouncer at a club. The hybrid search is the line outside, and the re-ranker is the guy at the door deciding who actually gets to go in first, based on the dress code. But wait, if the re-ranker is slow, doesn't that make the whole search feel sluggish?
It can, which is why you only run it on a small subset of results. You don't re-rank 10,000 items, you re-rank 50, and the re-ranker can take more into account than just the words. It can look at business metrics. If you have two pairs of shoes that are equally relevant to the search running shoes, the re-ranker can look at which one has a higher profit margin, which one is in stock, or which one has been clicked on more in the last 24 hours. It's dynamic.
This is where I saw Hilbert getting a bit stressed. He was looking at tie-breaking rules. He had this list: attribute ranking, business metrics, proximity. It felt like he was trying to program a brain. How do you explain proximity to a mere mortal?
Proximity just means how close the search terms are to each other in the text. If I search for apple juice, a document that says I love apple juice will rank higher than a document that says I have an apple in my bag and some orange juice in the fridge. The words are the same, but the distance between them tells the engine that the first document is a better match for this specific phrase.
That makes total sense. I think one thing people miss is that you don't have to let the AI do everything. I was reading Daniel's notes, and he mentioned that manually mapping synonyms is still incredibly powerful. If you know your customer is called trousers pants, just tell the system that. Don't wait for a semantic model to figure it out through math.
Hand-tuned synonyms are the low-hanging fruit of search, and plurals too. You'd be surprised how many basic search setups fail, because someone searched for apples, and the system was only looking for apple. Most modern tools handle this out of the box now with stemming, which reduces words to their root, but you always have to check. It's the human in the loop factor.
So let's talk practicalities. If someone is listening to this and they're looking at their own search bar, maybe it's an e-commerce site or a documentation wiki, and they feel like it's broken. What's the first thing they should actually do? Is there a diagnostic test?
Stop guessing. You have to measure. You can't tune a search engine based on vibes or one angry email from a user who couldn't find a specific product. You need to look at your recall and precision.
Okay, break those down for us. Simple terms. Imagine I'm 5 years old and I'm looking for my lost Legos.
Okay, imagine you have a box of Legos and some toy cars mixed in. Recall is, did I find all the Legos that were actually in the box? If there are 10 Legos and you only found 3, your recall is low. Precision is, of the things I pulled out, how many were actually Legos? If you pulled out 5 Legos and 5 toy cars, your precision is 50%. Usually, when people say search feels broken, it's either because the precision is low, it's too noisy, and giving them toy cars, or because of the zero results crisis.
The zero results crisis? That sounds like a summer blockbuster. Is that when the user finds absolutely nothing?
It's the ultimate failure. A user expresses intent. They want to give you money or find information, and you give them a blank page. In 2026, with the tools we have, a no results found page is almost always a configuration error. If you don't have the exact item, your semantic search should at least be showing related items. If someone searches for a specific brand of drill you don't carry, show them the best drill you do carry.
I've noticed some sites are doing that really well now. It says, we don't have that, but you might like these. It feels much more human. But does that ever backfire? If I search for brand X and you show me brand Y without telling me, I'm going to think your search is broken or that you're trying to trick me.
That's why the UI matters just as much as the back end. You have to be transparent. Label them as suggested alternatives or similar items. This is where that hybrid pipeline really shines. The keyword search tells you, hey, I found nothing for this exact name, and the semantic search says, but I found these things that are conceptually 90% similar. You use that data to drive the UI.
Let's talk about the 80-20 rule for search. I know you're a fan of this. How does it apply to Hilbert and his dashboard of sliders?
It's the only way to stay sane. If you look at your search logs, you'll find that 20% of your queries make up 80% of your traffic. People are predictable. On a clothing site, people are searching for shoes, shirt, blue, large. Don't spend 40 hours trying to optimize the search for vintage 1970s style breathable mesh yellow tracksuits if only one person searches for that a year. Optimize the top 20 queries first. Make sure those are perfect. Manual merchandising or pinning results for those top queries is totally fine.
Wait, pinning? You mean just hard-coding the top result? Isn't that cheating in the world of algorithms?
Yes, and you should cheat. If you know that everyone who searches for help wants the Contact Us page, just pin it to the top. Don't trust an algorithm to figure it out through click-through rates over 6 months. Use your human brain for the obvious stuff and let the AI handle the long tail of weird, specific queries. Search is a tool for the user, not a purity test for your engineering team.
I think that's a big takeaway. The goal isn't to create a perfectly autonomous system, it's to create a system that works for the user. Sometimes the most advanced solution is just a simple manual override. It's like having a GPS, but still knowing when to take a shortcut you know is faster.
It's about balancing that black box of AI with human control. That's where Hilbert was getting stuck. He wanted the Algolia AI re-ranking to do everything. But we had to tell it no. Even if the AI thinks this discontinued product is relevant because people used to click it, we need to demote it because we don't sell it anymore. You have to feed your business logic into the machine. You can't just set it and forget it.
This actually reminds me of something we talked about back in episode 1483 when we were looking at the costs of vector databases, the recall per dollar era. It's not just about how good the search is, but how much it costs you to maintain that goodness. For a small team, a full-blown re-ranking model on every query might cost more in API fees than the value it's adding.
That's a very real constraint. This is why I like the progressive rollout approach. Start with basic keyword search, see where it fails. Add fuzzy matching, see where that gets noisy. Then add a semantic layer only if you have a lot of conceptual searches, like people searching for moods or styles rather than specific part numbers. And only bring in the expensive re-ranking for your most valuable queries or high-traffic segments.
What about the searchable attributes hierarchy? Hilbert was moving product name to the top, then category, then description. Does that order really matter that much? I mean, a word is a word, right?
It's everything. If you match a word in the title, that's a much stronger signal of intent than matching a word in a 500-word description field. If I search for Apple, and one product is called Apple iMac, and another product is a cookbook that mentions apples in the description of a pie recipe, the iMac should win. If you don't set your attribute weights correctly, the pie recipe might rank higher just because it mentions Apple, 10 times while the iMac page only mentions it once.
The keyword stuffing problem. I remember the early days of the internet where people would just put free movies in white text on a white background 1,000 times at the bottom of a page to trick AltaVista.
Modern search engines are smarter, but they still need you to tell them what fields are high signal. Usually it's title, then tags, then summary, then description. And if you have brand, that's usually a very high signal field too. If someone types a brand name, they almost certainly want products from that brand, not products that just happen to mention that brand in a comparison chart.
So, we've talked about the tech, the tuning, and the hierarchy. Let's look at the future for a second. Daniel's prompt mentioned how search is moving toward conversation interfaces and RAG retrieval augmented generation. How does a small team prepare for that? Is it a totally different skill set?
This is the most exciting part. All the work you do to tune your search index today, organizing your attributes, cleaning your data, setting up synonyms, is exactly the same work you need to do for a good AI chatbot. A RAG system is basically just a chatbot that searches your database first to find the right information before it answers the user. It's search with a voice.
So, if your search is garbage, your AI chatbot will be garbage too. It'll just be a very confident, very polite liar.
Precisely. If the search retrieval finds the wrong document, the LLM will summarize the wrong document. Tuning your search parameters isn't just about the search bar anymore, it's about the data foundation for every AI feature you want to build. Whether it's a compare products tool or a support bot, it all starts with effective information retrieval. If you can't find the data, you can't use the data.
It feels like we're moving toward a world where the list of blue links is just one way to view search results. Sometimes the result is a paragraph, sometimes it's a chart, and sometimes it's just the search engine taking an action for you. Like, book me a table at a place with good pasta.
We're seeing that with agentic behavior. If I search for track my order, I don't want to link to a tracking info page where I then have to type in my number. I want the search engine to see the intent, retrieve my latest order number from my profile, and just show me the map. That's the useful information retrieval Daniel was talking about. It's moving from, here are things that match your words, to, here is the solution to your problem.
Okay, so let's wrap this into some concrete takeaways for the mere mortals. If you're starting from scratch or trying to fix a messy system, what are the steps? Let's give them a checklist.
Step 1. Audit your data. If your product descriptions are messy, your titles are missing, or your tags are inconsistent, no amount of AI re-ranking is going to save you. Garbage in, garbage out. Clean the house before you invite the AI over for dinner.
Step 2. Set your attribute hierarchy. Title is king. Everything else follows. Don't let a match in a random comment section pull a result to the top. Make sure your brand and category fields are weighted heavily.
Step 3. Implement a hybrid pipeline. Don't choose between keywords and vectors. You need both. Use keywords for precision-like part numbers and exact names, and vectors for vibe and intent. Most modern platforms make this a one-click integration now, so there's no excuse not to do it.
Step 4. Tune your tiebreakers. Use your business metrics. If two things are equally relevant, show the one that's actually going to help your business, whether that's the most popular, the newest, or the one with the best reviews. Oh, don't leave it to chance.
And step 5, monitor your zero results searches. This is the most valuable data you have. It's a direct window into your customers' minds. It tells you exactly what your users want that you aren't giving them. It'll tell you which synonyms you're missing, which typos are most common, or which products you need to stock.
I feel like I could actually go back to Hilbert now and not just blink blankly at him. I might even ask him about his cross-encoder latency, just to sound smart. Hey Hilbert, how's the inference time on that re-ranker looking?
He'd love that. He'd probably talk your ear off for 3 hours. Just don't ask him to explain vector quantization unless you have a very large coffee and nowhere to be. That's a deep, dark rabbit hole.
Noted. I'll stick to the high-level stuff, but honestly, it's heartening to know that even though it's complex, it's more accessible than ever. You don't need a PhD in data science to have a world-class search experience anymore. You just need a bit of curiosity, a decent tool set, and the willingness to look at your logs.
And a legendary producer like Hilbert Flumingtop to do the heavy lifting when the vectors get too heavy.
Speaking of Hilbert, thanks as always to our producer Hilbert Flumingtop for keeping the engines running and making sure our own search bar actually works. He's the real hero of the operation.
And a big thanks to Modal for providing the GPU credits that power this show. They make the heavy computational lifting of modern AI feel as easy as a well-tuned search bar. Without them, we'd be doing this on a calculator.
If you've enjoyed this deep dive into the black box of search, consider leaving us a review on your favorite podcast app. It really does help other mere mortals find the show and understand the tech that runs their lives.
This has been My Weird Prompts. You can find us at myweirdprompts.com for the full archive, show notes, and all the ways to subscribe. We've got a lot of back episodes on similar topics if you're hungry for more.
I'm off to go tie crimson joggers into our site and see if Hilbert's tuning actually works. If I get a list of red pants, I'll know he's a genius.
And if you get a list of red cars, we might need another episode. Good luck with that. See you next time.
See ya. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our